In today's lab, we saw this effect happen with the tea bag and the flame. So as the tea bag was lit and the flame traveled down, then eventually got to a point where it would rise upward. And in this reaction, we're looking at an example of a combustion reaction, and a combustion reaction occurs when oxygen reacts with some kind of, in this case, a hydrocarbon, the paper, and then the products come out the top of the flame. And so we're looking at here, we have cooler air entering the bottom, warmer air entering the top, and there's something called a convection current. A convection current is basically what happens in the air or in water that boils, where warm air or the warm liquid, any kind of fluid, will rise and the cool air will be at the bottom. So in this case, we have this these warm products rising out of the top of the tube and causing the tube to fill that void as the products come out. In general, combustion reaction is a reaction between a hydrocarbon and oxygen. It forms carbon dioxide and water as products. When we think of combustion, we of course think of fireworks and firecrackers and anything that causes, then we see sparks or flames or those kind of things. And basically you have this hydrocarbon that reacts with oxygen, as you can see on the right hand side, produces carbon dioxide, water, and of course energy. Combustion reactions generally are very hot, and the heat is released as an exothermic reaction. As with all the chemical reactions we've looked at so far this semester, we must be looking also at balancing these equations. Let's look at a short example here of balancing this equation.
Okay, so looking at the combustion of methane, if you look on your reactant side, we have one carbon, and on your product side, we have one carbon. So carbon's already balanced. Looking at hydrogen next, we have 4 on the reactant side, but only 2 on the product. So if we stick a coefficient of 2 right here, that would double our hydrogen and double this oxygen. So now we have 4 hydrogen. Taking into account oxygen, on our reactant side we currently have 2, and on our product side we have 2 from the carbon dioxide and then another 2 from the water. So that's a total of 4 oxygens. And so to balance out our 4 oxygens on the products with that on the reactants, we should stick a coefficient of 2 in front of the oxygen.
So as you can see, no different than any other chemical reaction that we've balanced during the semester. This is just a specific category of a chemical reaction. So enjoy filling out your answers here on the questions. Make sure you answer them to the best of your ability, and we will look at this in class tomorrow. Thanks!